Dear students, I am Manoj K Bandil. In this video lecture, we are going to discuss about the subject that is basic electrical and electronics engineering. This is one of the very core subjects belongs to the electrical and electronics engineering, and it's required for all the discipline branches in the engineering to understanding the basics of electrical and electronics. So basically, what is the scope of this subject? This subject that is basic electrical and electronics engineering gives you basically the knowledge of fundamental knowledge of the concepts belongs to electrical and electronics engineering. And the aim of this subject is to provide students the basic understanding of DC and AC fundamentals, AC circuits, that is single phase, three-phase circuits, transformers, rotating machines, in which we are having both DC and AC machines, battery, analog devices, digital electronics, which is covering basically the basic electronics required for basic functioning understanding in the field of electrical and electronics industry. As we all know that, can you think about that you live without electricity? Can you think live without your electronics gadgets? No, because this is a part of present scenario, the present life. No industry run without electricity. So that is why you should be aware about these fundamentals of the both electrical and electronics engineering. As far as this subject concerned, this subject scope, basically we are going to acknowledge the students about the charge, current, voltage, basic laws of electrical engineering, networks theorems. To analyze practical sources and ideal sources, measuring devices, just like ammeter, voltmeter, etc., wattmeter. The students are going to acknowledge about the single phase, three phase. What do you mean by the single phase, three phase supply? AC circuit analysis, power generations, AC power generations, DC power generation, distributions. What is the magnetic circuit behavior? What is the behavior of the electrical machines, just like transformer, DC machines, AC machines? Having the knowledge, basic knowledge about these machines, that maybe the transformer, DC machines, AC machines, and basic electronics for effective functioning, understanding, which belongs to the electrical and electronics industry. Now we are focusing on the course contents of this subject. Basically, we are, as per the RGPV, the course curriculum and syllabus and scheme, we are having the 5 units. So in the unit 5, total unit number of 5 units, the unit number 1, Basically, we are discussing about the DC circuits. In the DC circuits, we are discussing voltage and current sources, dependent and independent sources, their measuring units. So means we are having the consideration of all these voltage and current sources, in which categorizes like the dependent independent sources. We also learn about the source conversion. That means the current source is going to convert it into the voltage source and voltage source into the current source. Sometimes during the analysis, and we are going to applying any network theorem, it's convenient to us when we are going to convert any particular voltage source into the current source. Basic laws, Ohm's law, Kirchhoff's law, basic fundamental laws, and we are going to apply these laws for the circuit analysis. And in the unit number 1, we are basically focusing on the DC circuits, DC networks, all the network topologies. And we are going to apply these laws, Ohm's law, Kirchhoff's law, and also we are trying to learn the source conversion in these units. As far as the network theorems, we are learning this superposition theorem, Thevenin theorem, and also we are going to discuss their applications, how we are going to apply these superpositions and theorems. So the application for analysis of the series parallel resistive circuit as excited by the independent voltage source, and also we are going to find out the power and energy calculations in such circuits. Two more popular approach for the network analysis. One is your mass and another one is your nodal analysis. Or we are going to apply these mass and nodal analysis to network analysis. And star delta transformations means my elements are connected in the star and my elements are connected in the delta. So means if we are going to convert into the star into delta and delta into the star, sometimes the complexity of the network is going to reduce. So as far as the unit number 1 concerned, we are discussing all these things as a concern about the analysis of DC circuits. In the units number second units. Unit number 2, we are basically having two considerations, two topics. One is your single phase AC circuits. In this single phase AC circuit, we are going to learn about, first thing is important, generation of sinusoidal AC voltage. We have the equations for the AC generations. How AC voltage is going to generate it. We must know about how this generation is going to possible, how I'm going to represent my generated AC voltage. We also define some terms like average value, root mean square value, and also we are learning two important factors, form factor, peak factor of AC quantities. That AC quantity may be the current, may be the voltage. Very important concept as far as the understanding for the AC circuit analysis. That is the concept of the phasor. It's the concept of the phasor is very important as far as the AC circuit analysis concerned. Not only for the AC circuit analysis concerned, whenever we are going for AC machines analysis, we are basically this concept is very fruitful for understanding and analyzing to elaborate the problems related with the design, etc., efficiency everywhere, to learn the basic behavior of these machines. It's very useful fundamentals. So we learn about the phasor, phase difference, etc. One of the important factor, that is a power factor, is very important factor as far as the power system concerns. It gives us very important informations This factor gives us information about the efficiency, utilizations of the electrical power. So we are going to discuss this power factors and its importance. Two important terms, impedance and admittance. These are basically these are the impedance and admittance are useful for the circuit analysis. Just like for the series circuits analysis, we are basically having this concept of the impedance is very fruitful, and then the parallel circuits admittance concept is very fruitful. These two concepts are basically as far as the complexity of the calculations or analysis concerned. Whenever I'm taking the impedance into consideration, it's very simple to apply in the series circuits. And as far as the parallel circuit concerned, admittance is very easier way to apply, and it's reducing the too much complexity of the mathematical calculations. Active, reactive, apparent powers. Analysis of RL, RC, RLC series and parallel circuits. So this is a unit having one of the part that is belongs to the single phase AC circuits. Another parts in which the second unit is having, it is basically three-phase AC circuits. In the three-phase AC circuits, we are learned that why this three-phase circuit, three-phase supply is necessity and the advantage of the three-phase system. What is the meaning of the phase sequence? Is important terms, one of the important key terms, just like a phase, sequence, line voltage, phase voltage, line current, phase current. So one of the sequence, phase sequence, balanced, unbalanced supply and load. Relationship between line phase volume of the balanced star and delta connections. Power calculations in balanced and unbalanced three-phase system, and also their measurement, the power measurements for the three-phase star connected system, three-phase delta connected system. So this is basically these units having the broad covering of the two interrelated concept, that is the single phase and three-phase circuits. In the third units, basically this is the third unit, we can say it's a fundamental for the electrical machines. In this particular third units, we have first important concept of related with the magnetic circuit, in which we are covering basically definitions, magnetization, characteristics of the ferromagnetic materials, self inductance and mutual inductance, and in their associated energy, and their coil connected in the series, coefficients, AC excitation in the magnetic circuit, how the magnetic field is going to produce by the current carrying conductors. They're associated with the different laws, work law, etc., Ampere's law, forces on the current carrying conductors. We are also covering the difference between the magnetic circuit and the electrical circuits also. Induced voltage, laws of electromagnetic induction, that is Faraday electromagnetic inductions, direction of the induced EMF, Lenz law, etc. Basically, all these things are basically fundamentals for the electrical machine point of view. To understand the basic functionalities of the electrical machines, to understanding of this concept related with the magnetic circuit is very essential. Without understanding the basics of magnetic circuits, we are not able to understand the functionality of the electrical machines. So in this third units, we are also covering the single phase transformer. In this transformer, general constructions, working principles, EMF equations, equivalent circuits, phasor diagrams, voltage regulations, losses and efficiencies, open circuit and short circuit test. In the fourth unit, we are having the different types of electrical machines. Now in this units, we are having the rotating machines. And in the first one, in the third unit, we are covering the static machines, one that is the transformer. In the unit number 4, we are having the rotating machines. And in this particular construction, classification, working principles of DC machine, induction machine and synchronous machines, working principle of three-phase induction motors, concept of the slip, very important term, that slip in three-phase induction motors, torque slip characteristics of the three-phase induction motors, and the losses, types of the losses occurring in the electrical machines. And also we are learning the applications of the DC machines, induction machines, and synchronous machines. Unit number fifth, in this unit fifth is belongs to the basic, all coverings to the basic electronics. In this units, we are covering number systems, their conversions used in digital electronics, De Morgan theorems, logic gate, half and full adder circuits, RS flip-flop, JK flip-flop, semiconductors, diode, VI characteristics of the VI junctions transistors, BJT, and their working, different biasing, common collector, common base, common emitter, transistor configuration, different configurations, and mode of operations. So basically, this after learning all these things in this subject, we have the capabilities. This subject has been introduced for the undergraduate students to understand and develop the concept of the basic electrical engineering. Basic electrical and electronics engineering for all the undergraduate students of the different branches of the engineering. Basically, the outcomes of this subject is understand the basic essential terms in the electricity and networks, Ohm's law, Kirchhoff's law, superpositions, Thevenin, their applications, understands DC and AC fundamentals, analysis of AC circuit like RL, RC, RLC series parallel circuits, necessity and advantage of the three-phase system, meaning of phase sequence, balance, unbalance, understand single-phase transformer, electrical machines like DC motors, DC generator, three-phase induction motors, synchronous machines, their general construction, working, and EMF equations, and the semiconductor devices, rectifier circuits, basic application of the transistors, use binary, octal, hexadecimal numbers, define logic gates, describe significance of Boolean algebra in the digital circuits, understand the working principle of logical circuits, define flip-flops, and describe behavior of various flip-flops. So the final outcome of the subject will result into enhancement in the understanding the basic concept of core electrical and electronics engineering. The topic covered under this subject will help to enhance the basic understanding of electrical machines and power system and basic electronics. As far as the research scope concerned, electrical and electronics engineering influence every aspect of our modern lives. Develop and design new innovations, technologies, and also find ways to improve the existing one. Just like this, we are going to continue in the illuminations point of view. We are going to replacing our traditional bulb with the LED, CFL. So it's a continuous innovations in the field of fulfilling the daily requirements of a human being in a more easier manner and more energy efficient manner. These are the references, the different books belongs to the references in this subject that is basic electrical and electronics engineering. I hope that you will be aware about the importance of this subject, that is basic electrical and electronics. This is one of the essential subjects to provide the basic understanding in the field of engineering, whatever your branch, whatever your stream. Basic understanding of this subject is very, we can say it's a build up one platform which provides a bright future, bright understanding for the electrical and electronics engineering to implement in each and every field of engineering. Thank you very much.